All right, here's our video today, the sleeping black hole. Sleeping Beauty. So the James Webb Telescope just recently, and recently is, well, to you it may not be recently if you're watching this later, years in advance. But anyway, they discovered this tremendous black hole, and it seems to be taking a nap. It's napping. They call it the napping black hole, or the sleeping black hole, after overeating. And you may know the feeling. You know, you eat this giant Thanksgiving dinner, then you hit the couch and you're out. Just pass out, right? Nap time after eating. So astronomers discovered this black hole, and the problem is that it existed 800 million years after the Big Bang, which is problematic, and we'll talk about that in the video. So basically, it ate up some delicious galactic gas and then passed out, so to speak. So we'll talk about that. By the way, the black hole is 400. Let's write that down. Let's get a pen going here. We'll use red. It's 400 million times. That red's not coming out. Let's change it. Let's change it to yellow. 400 million times more massive than the sun, than our sun, our yellow dwarf sun. To put it in perspective, think of an ant. You know, a little ant to a human is not even close to that. Because a human, if you know what these creatures are, humans, they're about 35 million times more massive than ants. So 400 million it's enormous. And in our Milky Way, we have a black hole. And this Sleeping Beauty black hole, by the way, is not in our Milky Way. It's very, very far away. It's 10.4 billion light years away. So it's very far away. So in our Milky Way, we have, in the center of our Milky Way, it's 27,000 light years away from Earth, is Sagittarius A, and it's 4 million times more massive than the sun. So we have this black hole that they discovered 400 million times more massive, and then Sagittarius A in the center of our galaxy, which is 4 million times more massive than our sun. Let's get a picture of that. So again, let me write it down for you. Sagittarius A. It's our black hole, and it's over here in the center of our galaxy, right? And we're somewhere over here. Who knows? Somewhere around there. And the largest known so far, the largest known black hole is called Ton 618. And it's enormous. It's 66 billion times more massive than our sun. There we go. 66 billion times more massive than the sun. And the thing about our Sleeping Beauty black hole is it possesses 40% of its host galaxy. Sagittarius A, if you think about the mass of Sagittarius A compared to our entire galaxy over here, we'll put the mass, it's 0.0004%. Ton, by the way, in its own galaxy, Ton 618, compared to its galaxy, has 6.6%. But this Sleeping Beauty has over 40%, so it's enormous. Well, it's not bigger than Ton 618, but the fact that it has 40% of its galaxy's mass is interesting and problematic. Now, when black holes aren't feeding anymore, they should be invisible. You shouldn't see them because they're not feeding. And so the Sleeping Beauty, scientists think it still should be feeding. Yet it's dormant, and there's the puzzle right there. Let me get a picture of a black hole with its event horizon and explain that. So black holes are surrounded by a cloud of matter and gas right here. This, as you can see this picture here. You can see in the picture the accretion disk. That's where all the matter and the gas are surrounding the black hole. And what that does is it causes this immense friction. But the thing is, it should still be feeding. So the reason they detected it is because of its enormous size. So in simple term, here's the problem. Let's make sure my pen's working. You have two types of how black holes could form. So on one type, you have collapsed stars. Stars that are very massive could collapse into black holes. Not our sun. Our sun's much too small for that. But then you have another section, and they're called mergers in a sense. And they merge when like two black holes form, two or more. Two black holes merge. And usually what happens is, what that happens as they're consuming gas from the galaxy, that usually takes over 1 billion years or more. That's what scientists think. And yet when they detected the Sleeping Beauty, they think it was created less than 800 million years ago. It's close to 1 billion. They think it's much too early for it to be that massive. And there's another word we'll talk about here, is the Eddington limit. Let's put it over here. Actually, let's clear this out. Let's put it over here. The Eddington limit. The Eddington limit. So the Eddington limit basically is saying it's the point where the food supply just basically is cut off. So perhaps the radiation is when it's feeding off this radiation. The radiation kind of pushes the extra gas out, and maybe it has reached its Eddington limit. But that's still a question for scientists. And that's our video today.